In this lesson, we'll learn how to solve radical equations of the given form through solution of examples. Let's get started with example number 1. The given equation, given radical equation is 4x squared plus 4x minus 21 square root plus x squared minus x minus 6 square root equal to 6x squared minus 5x minus 39. This type of radical equations which have quadratic expression in each of the term, there is one factor which is always common. So we are going to factorize each of the expression. Here x squared plus 4x minus 21. That would be AC is equal to negative number. Therefore, we should find two such factors of 21 whose difference is equal to 4. So those are x squared plus 7 minus 3 x minus 21 and x squared plus 7x minus 3x minus 21, and if we take x common, this would be x plus 7 minus 3 common, x plus 7, and we'll have factors as x plus 7 into x minus 3. These are all factors of the given expression. So let's solve the second expression, which is x squared minus x minus 6. Again, AC is negative, so we must find two such factors of 6 whose difference is equal to 1. So this would be x squared minus 3 minus 2 x minus 6, x squared minus 3x plus 2x minus 6, x common, x minus 3 plus 2 common, x minus 3, and we have factors as x minus 3 times x plus 2. So these are two factors of the second expression. Now similarly, let's factorize the third expression, which is 6x squared minus 5x minus 39. Again, AC is a negative number. Therefore, we must find two such factors of the product of 6 and 39 whose difference is equal to 5. And two such factors of product of 6 and 9 are 18 and 13. 6x squared minus 18 minus 13 x minus 39, and if we take 6x squared minus 18x minus time minus will become plus 13 x minus 39, and here if we take 6x common, inside would be x minus 3 plus 13 common would be x minus 3 again. So here we have two factors, x minus 3 times 6x plus 13. So all the expressions have been factorized. Let's put the values back. This will give us x minus 3 times x plus 7 square root plus x minus 3 times x plus 2 square root equal to x minus 3 times 6x plus 13 square root. If we take common x minus 3 square root, x minus 3 square root times x plus 7 square root plus x minus 3 square root times x plus 2 square root minus x plus x minus 3 square root times 6x plus 13 square root equal to 0. And now we can take x minus and root 3 common. X minus 3 and root is common time x plus 7 square root plus x plus 2 square root minus 6x plus 13 square root equal to 0. Since the product of two real numbers can only be 0 when at least one of them is equal to 0, so either x minus 3 square root is equal to 0 or x plus 7 square root plus x plus 2 square root minus 6x plus 13 square root is equal to 0. If so, from here we get x equal to 3, or we get x plus 7 square root plus x plus 2 square root is equal to 6x plus 13, which is exactly of the type which we did in previous lesson, and we will simply apply the same formula or the same method to solve this kind of radical equation. So for this purpose we are going to take square on both sides, taking square on both sides. This would be x plus 7 plus x plus 2 equal to plus 2 times, this would be x plus 7 times x plus 2 equal to 6x plus 13. 6x plus 13. And now we simplify, and the terms on the left hand side when added will become 2x plus 9 plus 2 times, we can write both factors inside one square root. That would be x plus 7 times x plus 2 equal to 6x plus 13. And we isolate square root as part of our method on one side, moving everything else on the other side. So this will give us 2 times x squared plus 9x plus 14 equal to 6x minus 2x plus 13 minus 9, and this is 2 times x squared plus 9x plus 14 equal to 4x plus 4, and now dividing both sides by 2, dividing both sides by 2, what we get is x squared plus 9x plus 14 equal to 2x plus 2 square root on this side. Yet we haven't divided, we divided but we haven't taken the square. Now we'll take the square. Taking square on both sides, taking square on both sides, will have x squared plus 9x plus 14 equal to 4x squared plus 4 plus 8x. And now everything will go on one side so that we can have a standard quadratic equation. 4x squared minus x squared plus 8x minus 9x plus 4 minus 14 equal to 0. So this gives us 3x squared minus x minus 10 equal to 0, which is standard quadratic equation, which is standard quadratic equation. Okay, now we'll solve it by factorization, and for solving it by factorization, this is 3x squared minus, because AC is negative again, so we have to find two such factors of 30 whose difference is equal to 1, which are obviously 6 and 5. So 6 minus 5x minus 10 equal to 0. This is 3x squared minus 6x plus 5x minus 10 equal to 0. This means if we take common 3x, inside is x minus 2 plus 5 common, inside is x minus 2 again, and this leaves us with product of x minus 2 into 3x plus 5 equal to 0. Since the product of two real numbers can never be equal to 0 unless one of them is equal to 0, so either x minus 2 is equal to 0 or 3x plus 5 is equal to 0. Here x becomes equal to 2 and x becomes equal to minus 5 over 3, and we already have one root which we calculated above, that was x equal to 3. Therefore the solution set is, so the solution would be equal to 3, 2 and minus 5 by 3. Similarly, we can do the other question.